Okay, so this is going to be a plot of 20 samples with confidence intervals, and the dot will be the mean, and then this length will be the interval. So it's a vertical, so this one has a mean right here, about 18 3/4, and its standard deviation divided by the square root of the sample size times the 2-ish, 1.96 I think, makes this length. So 95% confidence intervals have been created at this time. Now, of course, if you do 20 samples, which you can see we're going to do, these down here just indicate the number of the samples. So first sample, the second sample, third sample, and so forth. There will be 20 of them. 95% of 20 is 19. So we would expect the true mean to be within the interval 19 times out of 20, because the confidence interval of 95% means that the true mean should be in there 95% of the time. So we let this go. This is a first sample, and then pretty soon the second sample will come, and there's its mean. Its standard deviation was larger, so we got a larger confidence interval here. The third one has the same-ish standard deviation. This is about the same length, but the mean is really quite different. So I'm going to let this go ahead and go. It should fill all the way out, so all 20 samples are going to be there with their mean and their confidence interval. Now you can see that there's a lot of overlap here kind of across the middle swath, that they are next to each other. Basically, if you do this width, they all intersect with that. But what if we just wanted to know about like a particular line? Okay, so let's look at it. If we put a line at 18, not a big swath of stuff, there's 1, 2 that it doesn't cross. So it misses 2. So if the mean were 18, that would be 90% of the time that it was crossing over. So what if we move that line up to 19? At 19, I guess I need to back up slightly. At 19, it misses 1. It barely touches that one, but it touches it. So this is the only one it misses at 19. At 20, it misses this one, and that's the only one it misses. And then 21, now it misses 1, 2. It barely misses that one, but it misses it. So it misses 2. So if we have to make a guess about the mean, since the mean should be in 95% of the intervals, we should guess 19 or 20. So the actual population from which these samples were taken did in fact have a mean of 20. So if we put a line across 20, should happen any second. Okay, so we put that line across, and we can see that that's the only guy it misses. So sure enough, it hits 95%, but you could argue so did 19, and that's true. The other thing is, though, we can take different levels of confidence. So let's take, for example, 85% confidence. That's going to have then a smaller z-score, right? We don't need to be as sure. So we can let that target get smaller because we don't need to be as sure that we're going to hit it. So we'll have a lot shorter intervals. So here's a plot of samples that were 85%. And here's the mean again. And you see the 3 red ones? We missed 3 because we're going to miss 15% of the time. 15% of 20 samples is 3 samples. So that means 3 out of 20 will miss it. So when you guys go to do these confidence intervals yourself, you won't necessarily capture the true mean. And you may have a different length of interval than someone else does for the T samples where you're using your standard deviation. Your Z samples should have the same length, but will have a different mean. So you won't all be the same. So now I have created a list of random numbers. I made them, I think, 18 to 75. I had in mind that they were ages of people in a college class. Of course, it wouldn't be like this. It'd be a whole lot more on the left end, be very, very right skewed, but I just wanted to randomize some numbers. So I'm going to use Excel to calculate, in fact, insert a column here. So I'm going to first do the mean of the whole population because I have the population, right? I've got 100 of them. This could also be taken into RStudio if I saved it as a CSV. I've given you a video on how to do that also. But I'm going to do it here. And so far, oops. Okay, so there's the mean. And the standard deviation is going to be kind of a process. So first, I'm going to come over here. What was my mean? 45.74. I'm going to say equals whatever this is, which is B1, minus 45.74. Because remember that the standard deviation is the RMS of the deviations from the mean. So I'm going to copy that down. So now I have the deviations from the mean. Some of them are negative. Oh, darn. Okay, so some of them are negative because they're below the mean. So the mean is about 45. This one's going to be negative because it's lower. This one's going to be positive because it's higher. Then I want to square that. So C1 squared. And then copy that down. And then what I want is the average of these. So I could put that on the mean line, but not exactly the average, right? I want to subtract 1. So I want equals sum D1 to D100 divided by 99, just one fewer. But then I need to take the square root of that if I want the SD. Okay, so now I've done the deviations, I squared them, I added those up and divided by 99, and here I have the standard deviation. So 16.838. Okay? So now that we have that, what I'm going to do is I'm going to go take samples in some random way, and I could use like a random chart. I could do a random number generator to have it choose for me, which is how I got these anyway. So let's say that I want a sample of size 5. I'm going to go equals rand between 1 and 100. So that's going to choose the position for me. So that's one way. You could also say, well, I'm going to roll a die, a 20-sided die, pick a number between 1 and 20, and then go 20 out from that each time, and that'll be 5. So this chose 35, but when I copy this, it changes it. So now I have 80, 82, 23, 76, and 34. So 23, that's one in my sample. 34 is in my sample. 76, 80, and 82. So that's going to be my sample. So my sample is 56, 35, 74, 21, 61. Okay, I'm going to use now the TI calculator and the list function. I'm going to move this over. I can see my sample. Okay, so I want a new document first of all, and I want to add a list. And I'll probably name it, so I'll just name it, I was pretending it was age, so I'm going to name it age. 56, 35, 74, 21, 61. Okay, now I want to insert statistics. I'm not sure how to use this tool, I guess. I don't really know why it's doing this. Let me go back on here and see if I right click. This is different from the calculator. I've opened the calculator here, so hopefully this will help. So I'm going to go menu, and then 4 is statistics. And the first thing that I ask you to do is actually to calculate the mean and standard deviation, and you can do that with one variable stats. And we just want one list, and it is list A, and the resulting column B is fine. So A was the list they used, B is where the results show up. So we have the mean. The mean of our list is 49.4, and the standard deviation of our list is 21.2. So the first thing that I asked you to do here is to find those, but the next thing I asked you to do is create a confidence interval using only your sample data. So if we're just using sample data, we do not know the population standard deviation. Make sure this is running. Okay. We don't know the population standard deviation. We're pretending. Okay. So in that case, what we do is do a t interval because we don't know the population values. We go to statistics, confidence intervals, t interval, and we tell it to use the data because we have the data. The data is the list. So if you're going to give it a mean and a standard deviation, then you choose stats. If you're given it a list, you choose data. Okay, and we want to use list A still, which is also called age because I named it that. And let's say that I want a 95% confidence. Then I would leave that 0.95. Okay, so then I get the lower and the upper. And because my sample is so small and my standard deviation is so big, it's a huge interval. So let's suppose that instead I wanted to put stats and do a z interval. For the z interval, I need to have this standard deviation right here, 16.838. And for the SE, for a sample size of 5, I would take that and divide by the square root of 5. If it was a sample size of 20, I'd divide by the square root of 20. Okay, so here's my SE, 7.53. So then if I go to the menu, and my mean here is 49.4, I'm always going to use my sample mean. I would never create a confidence interval with the true mean because I'm assuming I don't know it. Okay, and note, of course, the true mean is inside here. Okay, so then I would go to menu and say, oops, I'm not sure if I hit, let me use numbers instead. So 4, 3, I want to do a Z, And I don't want to give it the data because I don't have data that uses both my sample mean and my population SD. So I go to stats and I tell it the standard deviation, which is 16.838, and I tell it the mean, which was 49.4, I think, but I can't see it now. And N was 5. And I'm going to leave the confidence so that we can compare the two. That's my mean, 49.4 it was. Okay. So now you can compare these directly. So this was a much larger interval than this one. Sometimes this would be smaller than this one. It just depends on your sample. You can get a huge standard deviation or a tiny standard deviation. So again, this is the t interval was from using our sample standard deviation, and that would vary from person to person in length even, but the average length would probably be about the same as this one. And then this is from using the sample standard deviation to create the standard error. And the standard error they used was this. So this ME, that's the total error, like the width either direction from the mean. And the reason that it's just kind of almost double this would be 15.06. It's almost double that because remember the z-score is 1.96 actually and not 2. Okay, so this is how you create the confidence interval on a calculator using lists. The longer your list, the more you have to type in that first column, but once you've got those entered, everything else is all the same. And if you want the one variable stats, we're going to choose age. Oh, come on. And that's going to give us, whoa, going crazy here. Okay. That's going to give us the mean, which is the same, of course. The sum of all the x's, which was before they divided by 5. The sum of the x squareds, that's a part of the standard deviation formula. Sample standard deviation, population standard deviation, the number in the sample as though you didn't know it. It gives you the 5-number summary right here. So all of those things can be found on a calculator. So when you're going back to do some of the earlier work, if you need to, you can use the calculator for these things instead of RStudio. So that kind of concludes this how to use the calculator portion and what these things look like. And then I'm going to go back and record one that sounds like the seminar I previously gave you guys. On what a confidence interval does and how to build one by hand. Actually, maybe I'll just say that real quick. So basically what we're doing is you find the mean, and that's the middle. So if you look at these, where did these go? There we go. Okay, so these are going to be centered around the mean. 49.4. And what you do is you find the z-score based on the z-table. So if I want a 95% confidence interval, that means that I want an interval that has 95% inside it. Okay? That means between the two of these is 5%, which means just a single one of them has 0.025, because this is 0.05. So I want to look up 0.025 in the table. And there's a separate t-table, which we haven't really gone over yet. So for the moment, we'll look at the z-table. I've just pulled this up, which will hopefully serve our purposes. So we want 0.025 in the area over here. 0.025. 5 right here. So C negative 1.96. So then what we do is we say, okay, so Z is negative 1.96, but that was this one. We actually want them both. It's going to be symmetric, so it's really just going to be plus or minus. Whatever that number is, it's always plus or minus because it's symmetric. So then we say, okay, well, here's the mean. So in our case, 49.4. And from 49.4, I want to go 1.96 standard deviations in one direction, and 49.4 minus 1.96 standard deviations in the other direction. And instead of standard deviation, we just call it standard error because it's on sample means instead of on individual values. And the standard error for population means, sample means, is the population standard deviation divided by the square root of the number in the sample. Now that is, normally we're not going to know this, right? So we approximate it using this, just the sample standard deviation, but then we need to use a t-table instead. So we wouldn't use 1.96, we'd use a different number. And I will make another video doing this from scratch for both Z and T and spend more time on it than I have just now. And probably they should be watched in a different order, so I'll put this one after it. But this is made kind of assuming that you've seen the seminar. So anyway, I'll do the other one maybe tomorrow, but maybe not. But anyway, by the end of the week.